Okay, so we've talked about the model we're going to use, and we've talked about where the term regression actually came from. Now it's time to write some Python code. One of the habits that I want us to get into when training our algorithms is to split up our dataset into two parts. We're going to shuffle all our data and divide our dataset into a training dataset and a testing dataset, because we want our algorithm to learn those theta parameters based only on the training dataset. And this means that we can use the other part of our dataset that hasn't been used for testing. Because with the testing dataset, we can see how our algorithm performs out of sample, how it performs on a dataset that it hasn't seen yet. Back in Jupyter Notebook, I'm going to add a markdown cell with a section heading that reads training and test dataset split. There we go. And in the cell below, I'm going to create two more variables. The first one is going to be called prices. And I'm going to set that equal to data, square brackets, single quote, price. So prices is going to hold on to our series of price data. And then we'll have features, which is going to be equal to data, so our entire data frame, then a dot. I'm going to say drop, and then in the parentheses, I'm going to have single quotes, price, comma, axis equals 1. What did I just do here? I took our entire data frame and I've dropped one column from it, namely our target values. And to accomplish this, I've used the drop method. So this method will return a new data frame, which I've stored in a variable called features, but this data frame will not include the price column. The second argument here, axis equals 1, is there to specify that we're looking to drop a column as opposed to a row. For a row, you'd have axis equals 0. For a column, you use axis equals 1. To split up our dataset in our notebook, we're going to make use of scikit's learn capabilities once more. But we're going to have to import this capability. We're going to have to add an import statement at the very top. I'm going to add from sklearn.model underscore selection import train underscore test underscore split. So that's all lowercase. From sklearn.model underscore selection import train underscore test underscore split. Let me hit Shift Enter on this cell and then go back to where we left off. Now this train underscore test underscore split function will actually return to us 4 values, a training and a testing dataset for both our features and our targets. So we'll have xtrain, xtest, ytrain, and ytest, 4 values that are going to be returned from this function. When a function returns multiple values, the Python syntax we'll use to store those values is called tuple unpacking. So let's create the variables that will hold on to the output from this function. It's going to be capital X underscore train, comma, capital X underscore test, comma, lowercase y underscore train, comma, lowercase y underscore test. And that's going to be set equal to train underscore test underscore split, parentheses, so the function itself. And now all we have to do is provide some arguments to this function call. So what arguments does this function need? Well, it has to know which features and which targets to shuffle and to split up. So the first argument is going to be our features variable, which we've created above. The second argument is going to be our prices variable, which we've created above. The third argument is going to be what kind of split that we want to make. Do we want to make a 50-50 split? Do we want to make a 60-40 split? What kind of split do we want this function to make? I'm going to go with an 80-20 split. So I'm going to say test underscore size is equal to 0.2. What this means is that our test dataset is going to be 20% of the total. Now, I could leave this function like this, but I'm going to add one more argument. And the reason is that this function will shuffle and split the data. However, this shuffling is random, right? So my shuffle will be different from your shuffle. If we want to get comparable results, then we have to shuffle our data set in exactly the same way. And to ensure that you and I can do that, let's supply another argument, the random state. So I'm going to say random underscore state is equal to, and then we can pick a number. As long as we pick the same number, we're going to be good. We're going to get the same shuffling. So I'm going to pick 10. Random state is equal to 10. Let me come over here and hit enter on my keyboard so that my line doesn't get too long and wraps a bit more nicely like this. Okay, so there's actually quite a lot going on in this line of code because we're shuffling all our data and then splitting it up. The thing about the shuffling is that there's a random number generator which will generate this randomness and do the shuffling. The last argument that we supplied here, this random underscore state argument, basically draws a line in the sand to kind of set the starting point for the random number generator that does our shuffling. If you and I both have the same starting point, then we get the same shuffle. Now, a question you might ask is, why shuffle the data? Right? What's the point? And the answer to that is that sometimes when you get a fresh data set straight out of the box, the data is actually in a certain order. A good analogy is a deck of playing cards. Did you ever buy a new deck of playing cards, or did you ever watch a magician perform a card trick on stage with a new deck? When you take off the plastic wrapper on a deck of playing cards, and you take the cards out of the box and you look through them, you'll notice that all the cards are in a certain order. Now, obviously, this means that before playing a card game with this deck, you have to shuffle the cards. Otherwise, you end up with a very, very terrible game of poker. In other words, the cards dealt have to be random. Otherwise, it defeats the purpose. And the same holds true for this training and our test datasets. The rows or the data points that are allocated to these datasets have to be random as well. There can't be a clear pattern in how the data points are allocated. And that's why it's customary to shuffle any dataset as well. So customary, in fact, that our scikit-learn's split function does the shuffling of our rows in our data frame automatically, and why we use this random state argument in the function call. Cool. And just like that, we've created an 80-20 split with our data from our data frame. But you don't have to take my word for it. You can verify the 80-20 split yourself. The percent of the training set will be the number of rows in xtrain divided by the total number of rows in the dataset as a whole. We can calculate this using the length function. So len parentheses x underscore train divided by len parentheses features will do this calculation. And that is equal to 0.7984. So very, very close to 80%. If you wanted to calculate the percentage of the test dataset, so percent of test dataset, you could do the same thing. You could get the number of rows in the test dataset and divide by the number of rows in the feature dataset. Another way to get the number of rows is to say x underscore test dot shape and grab the first element in the shape attribute. That's the number of rows. So x underscore test dot shape divided by features dot shape square brackets 0. And that's equal to 0.2. Brilliant.